Hey there, and welcome to Top Tutor SPM Modern Mathematics. Have you guys been busy with social networking? Thanks to the internet, we can now go beyond borders. That's called globalization, but in your day-to-day, you definitely need borders. For example, if you wanted to create a fountain, you would have to calculate the parameter to know the length of the fountain. And if you wanted to put some tiles down there, to make it look good, you got to calculate the area to know how many tiles you need to use. Now, usually I would be doing the teaching, but today I've got an even more masterful teacher to do it for me. Ladies and gentlemen, may I present to you, Cikgu Noel. How's it going, Cikgu?
I'm fine, and how are you?
I'm good, thanks. So, are you ready to teach these guys a lesson?
Of course, I can't wait to start.
Awesome. What's our topic for today?
Perimeters and areas of circles.
Fantastic. Let's go. Over to you.
In this topic of perimeters and areas of circle, there are generally just a few formulas that we need to know. Now, the first formula is regarding the perimeter of a circle, where perimeter of a circle is 2 pi r. Then we have to know the formula to find the area of a circle, which is pi r squared, where pi here is a constant value, while r is the radius of the circle, as shown in this diagram. Now, the next thing we need to know is how to calculate the length of arc of the sector OPQR, which is centered at O. Now, that will be equivalent to theta, which is the angle subtended by the sector, over 360 degrees times 2 pi r, which is the circumference of the circle. And to find the area of the sector OPQR, we have to take the ratio of theta over 360 degrees times the area of the circle, which is pi r squared. Now, sometimes you may need to use Pythagoras theorem, which says that the addition of the square of the two perpendicular lengths, well, in this case would be length A and B. Now, A squared plus B squared is equivalent to the square of the length of the hypotenuse. Therefore, you have C squared. Now, Pythagoras theorem here is very useful and it's very important to know how to utilize it. Now, all of these formulas here are given in your list of formulas in your examination paper. So it is not a question about how much you can remember, but rather it's a question about how you're going to utilize them in the question. So with this in mind, let's move into some questions and see how we can utilize them. Alright, now, in this diagram over here, we have OQR is a sector with center O, while OPQ is a semicircle with center T. Now, it is given that OR equals to 21 centimeters, so using pi as 22 over 7, we are supposed to calculate A, the perimeter of the shaded region, and B, the area of the shaded region. Now, perimeter is the length of the outskirts of the shape. So, when we are required to find the perimeter of the shaded region, we are actually looking for the length OR, arc RQ, which is based on the circle centered at O, and arc QPO, which is based on the circle centered at P. Now, notice that I've highlighted the two different circles. So be careful, do not include OQ as part of the arc for circles centered at T. Now, what do we do next? Since the question has given us the length OR, which is 21 centimeters, so that is done. We do not need to find them anymore. So the next thing we need to find is to find the arc RQ. Now, formula of the arc once again is theta over 360 degrees times 2 pi r, where theta is the angle subtended by the sector and r is the radius of the sector. So now, once again be careful. We are looking at sector ROQ, and therefore theta will be 30 degrees and radius will be 21 centimeters. Now, taking pi as 22 over 7, we're going to substitute these values into the formula. And we have 30 degrees over 360 degrees times 2 times 22 over 7 times 21, and that will give you the length of 11 centimeters, which is also the length of arc RQ. Now, to find the length of arc QPO, we have to be certain that it is not centered at O, but rather it is centered at T. So to find arc QPO, there are two ways that you can do this. Now the first way is to follow the formula. Angle subtended by the arc is 180 degrees and the radius of the arc is 21 over 2 centimeters. Because the length of OQ is 21 centimeter, therefore the radius of this semicircle is 21 over 2 centimeters. Now, utilizing the formula of length of arc, we have 180 degrees over 360 degrees times 2 times 22 over 7 and times the radius of 21 over 2, giving us the answer of 33 centimeters. Or we could just use a simple approach because we know that QPO is half the circumference. While the full circumference is 2 pi r, therefore all we have to do is get 2 pi r and divide it by 2. We will have pi r for the length of arc over semicircle. Therefore, we have 22 over 7 times 21 over 2, giving us 33 centimeters as well.
So therefore, the perimeter of the shaded region is equivalent to the length OR plus the length of arc QR plus the length of arc QPO, which is 21 plus 11 plus 33, and therefore we have 65 centimeters. So now it's time to move on to part B. Okay, in part B, we are required to find the area of the shaded region, and once again I'd like to remind all of you that the area is made out of a sector ROQ and a semicircle of QPO. Now we have to calculate these two areas separately simply because they are based on circles with different centers. So for sector ROQ, the radius is 21 centimeters while the angle subtended is 30 degrees. Therefore, the area of sector ROQ, well, in other words, OQR, is 30 over 360 times 22 over 7 times 21 squared, which is based on the formula of theta over 360 times pi r squared. And we will find that the area of the sector is 115.5 centimeters squared. Now, as for the semicircle of QPO, the radius is 21 over 2 centimeters. Because it is a semicircle, the angle subtended in between is 180 degrees. Now, there are two ways of calculating this area. Either we use the formula that we already know, or we'll take an alternative. Now, if we were to go by the formula will be 180 degrees over 360 degrees times pi, which is 22 over 7, times the square of the radius, which is 21 over 2 squared. And we will arrive at the answer of 173.25 centimeters squared. And that is the area of the semicircle QPO. Now, for the alternative method, we know that QPO is a semicircle, and we know that the full area of a circle is pi r squared. So all we have to do is take pi r squared and divide it by 2. So we have half times 22 over 7 times 21 over 2 squared. And that gives us the same answer of 173.25 centimeters squared.
Hence, the area of the shaded region is equivalent to 115.5 plus 173.25, which equals to 288.8 centimeters squared.
It's good to know a formula, but it's even better to know when and how to apply that formula. More after this break. When you think of a problem in perimeters and area of a circle, do you think a pizza? To understand the solution, you need to know what the problem is first. And you're halfway there.
So let's move on to the next question. Now, in this question over here, we have a diagram where ABCD is a rectangle while PQR is a semicircle centered at O. Now, PSO and RTO are two identical semicircles. So using pi as 22 over 7, we have to calculate the perimeter of the shaded region, and the area of the shaded region. Now, it clearly states that PSO and RTO are two identical semicircles. So that means they have the same radius, the same length of arc, and the same area. So, the perimeter of this shaded region is equivalent to arc PQR plus arc PSO plus arc RTO. So all we have to do is figure out the length of these semicircles and we can find the perimeter of the shaded region. So to calculate the perimeter of the shaded region, let us first find the length of PQR. Now we know that PQR is centered at O and the length of PR is 24 centimeters. So therefore, the length of OR, which is the radius of the semicircle PQR, equals to 12 centimeters. So to find the length of arc PQR, we have to use the formula of 2 pi r over 2, giving us pi r. So substituting pi as 22 over 7 and the radius as 12, we have the length of arc PQR of 37.71 centimeters. For the length of arc PSO, it is a semicircle, and knowing that PO is 12 centimeters, the radius of PSO is 6 centimeters. Therefore, once again using the formula of 2 pi r over 2, which is pi r, we substitute pi as 22 over 7 and r with 6. We can then find that the length of arc PSO is 18.86 centimeters. Since we know that the length of arc RTO is equivalent to the length of arc PSO, we can conclude that the length of arc RTO is equivalent to 18.86 centimeters as well. Finally, the perimeter of the shaded region will equal to arc PQR plus arc PSO plus arc RTO, which is 37.71 plus 18.86 plus 18.86, giving us 75.43 centimeters. Now for the last part of the question, to find the area of the shaded region, I know it seems to be very complicated because of how the diagram looks, but trust me, it is not. Now the area of the shaded region can be calculated by using the semicircle of PQR minus the semicircle of PSO and plus the semicircle of RTO. Now we know that semicircle of PSO and RTO are the same. Therefore, they cancel each other out. So that means the area of the shaded region is equivalent to PQR. Now, knowing that the radius of the semicircle is 12 centimeters, therefore we can calculate the area using the formula of pi r squared over 2. So by taking half times 22 over 7 times 12 squared, that gives us an answer of 226.29 centimeters squared. Alright, so that's all we have for you for today's episode. So now I'm going to pass you back to Razif.
Besides the formula, the main difference when you're calculating perimeter or the area of the circle is that when you're calculating perimeter, you're looking for it in centimeters. And when you're calculating the area, you're looking for it in centimeters square. And that's how you remember the formula. It's the tiny details that makes a difference, don't you think? It's what makes this individual so interesting. Well, that's it for Top Tutor SPM Modern Mathematics. We will see you guys soon. Later.